Good day, I'm Aleah. I'm Quilaton, a student from Binangonan campus in section of LFBN211A015 BC. In today's discussion, we'll be diving into chapter 1.1, which focuses on data and data interpretation. So here are the key points we'll be exploring. What is data? Characteristics of data, forms and types of data, what is information, data versus information, the importance of data and information, data interpretation, data visualization, types of data interpretation, and last, tips on solving data interpretation. So, what is data? The terms data and information are often used interchangeably, but they actually aren't the same. Data is defined as a collection of individual facts or statistics. Data can come in the form of text, observations, figures, images, numbers, graphs, or symbols. For example, data might include individual prices, weights, addresses, ages, names, temperatures, dates, or distances. Data is a raw form of knowledge, and on its own doesn't carry any significance or purpose. In other words, you have to interpret data for it to have meaning. Data can be simple and may even seem useless until it is analyzed, organized, and interpreted. In simple terms, data on its own doesn't really mean much. It's like raw knowledge that doesn't have a purpose yet. You have to interpret the data to give it meaning. It's like when you analyze, organize, and make sense of the data, that's when it becomes useful and meaningful. So in summary, data is just a bunch of facts until you analyze and interpret it to find meaning and insights. So now that we have a basic understanding of what data is, let's take a closer look at its characteristics. So these characteristics includes of raw materials. Raw materials is data like materials that haven't been processed or organized yet. It's the starting point from which valuable insights can be derived. Next, not organized. Data in its raw form lacks organization. It may be scattered, unstructured, or lacking a clear framework. Next, number 3, has a little value. On its own, data may not hold much value or meaning. Its true potential lies in how it's processed and analyzed. And last, number 4, each data will contribute useful information. Means every piece of data, no matter how small or insignificant it may seem, has the potential to contribute valuable information when analyzed in the right content. So now let's transition to discussing the different forms in which data can exist. So number 1, text. Data can be in the form of written words and characters, such as documents, articles, emails, and other textual information. Number 2, moving on to numerical data, encounter information represented through numbers and mathematical values. This can include measurements, statistics, financial data, and other numerical information. Next, number 3, data can also take the form of images or visual representation. This includes photographs, graphics, charts, and any visual content that conveys information. Next, number 4, shifting gears to audio data or voice, we have data captured through audio recordings or spoken words. These include voice memos, interviews, podcasts, and any other form of audio data. And lastly, we have data in the form of videos, which combines moving images and audio. This includes recorded videos, movies, presentations, and any visual content with accompanying sound. By understanding the characteristic of data and exploring its various forms, we gain a comprehensive understanding of how to extract valuable insight from this raw information. So next, let's go to two main types of data. Quantitative data. Quantitative data is provided in numerical form like the weight, volume, or cost of an item. Quantitative data seems to be the easiest to explain. It answers key questions such as how many, how much, and how often. Quantitative data can be expressed as a number or can be quantified. Quantitative data are easily amenable to statistical manipulation and can be represented by a wide variety of statistical types of graphs and charts such as line, bar graphs, scatter, plot, and etc. So, in simple terms, quantitative data can be easily analyzed and interpreted using statistics methods. It allows for precise measurements and comparisons between different variables. This data can be represented visually through various types of graphs and charts such as line graphs, bar graphs, scatter plot, and more. For example, if we want to understand the sales performance of a product, we can use quantitative data to determine the number of units sold, the revenue generated, or to growth rate over a specific period. This data helps in making informed decisions, identifying patterns, and predicting future events. So next, let's go to discrete data. Discrete data is a count that involves only integers. These discrete values cannot be subdivided into parts. This means this is a type of quantitative data that can be measured on a scale. It can have any numeric value and can be divided into small parts. For example, the number of students in a class, the number of workers in a company, the number of home runs in a basketball game, and the number of test questions you answer correctly. So next, continuous data. This data that could be meaningfully divided into finer levels. It can be measured on a scale or continuum and can have almost any numeric value. Or it is another type of quantitative data that can be measured on a scale. It can have any numeric value and can be divided into smaller parts. Example, the amount of time required to complete a project, the height of children, the square footage of a two-bedroom house, and the speed of cars. Next, qualitative data. This is a descriptive but non-numerical, like the name, sex, or eye color of a person. Qualitative data can't be expressed as a number and can't be measured. Qualitative data consists of words, pictures, and symbols, not numbers. Qualitative data is also called categorical data because information can be sorted by category, not by number. Qualitative data can answer questions such as how this has happened and or why this has happened. So qualitative data is all about understanding the characteristics and quantities of something rather than measuring or quantifying it. So let's go to nominal data. Nominal data is used just for labeling variables without any types of quantitative value. The name nominal comes from the Latin word nomen, which means name. Example, the first, second, and third in a competition, letter grades A, B, C, and etc. When a company asks a customer to rate the sales experience on a scale of 1 to 10 and economic stats low, medium, and high. Next, ordinal data. Ordinal data shows where a number is in order. This is the crucial difference from nominal types of data. Ordinal data is data which is placed into some kind of order by their position on a scale. So this data represents the order or ranking of numbers. It indicates the relative position or rank of the data, but does not provide information about the magnitude of the difference between them. For example, the first, second, and third position person in a competition, letter grades ABC, and etc. When a company asks a customer to rate the sales experience on a scale of 1 to 10, and last, economic status, low, medium, and high. Now let's jump to what is information. Information is defined as knowledge gained through study, communication, research, or instruction. Essentially, information is the result of analyzing and interpreting pieces of data, whereas data is the individual figures, numbers, or graphs. Information is the perception of those pieces of knowledge. For example, a set of data could include temperature readings in a location over several years. Without any additional context, those temperatures have no meaning. However, when you analyze and organize that information, you could determine seasonal temperature patterns or even broader climate trends. Only when the data is organized and compiled in a useful way can it provide information that is beneficial to others. So in simple terms, information is what we learn and understand from data. Data is the raw facts while information is the process and meaningful interpretation of those facts. It helps us make decisions and understand the world. Next, data versus information. Data is a collection of facts while information puts those facts into context. While data is raw and unorganized, information is organized. Data points are individual and sometimes unrelated. Information maps out that data to provide a big picture view of how it all fits together. Data on its own is meaningless. When it's analyzed and interpreted, it becomes meaningful information. Data does not depend on information, however, information depends on data. Data typically comes in the form of graphs, numbers, figures, or statistics. Information is typically presented through words, language, thoughts, and ideas. Data isn't sufficient for decision making but can make decisions based on information. So, in conclusion, it is important to understand the distinction between data and information. Data is a collection of facts while information is the organized and meaningful interpretation of those facts. While data alone is meaningless, information provides context and allows us to make informed decisions. By analyzing and interpreting data, we can transform it into valuable information that helps us understand the bigger picture. So remember to both data and information is your decision making process. Next, importance of data and information. Why does the distinction between data versus information matter for businesses? Organizations that prioritize collecting data, interpreting it, and putting that information to use can realize significant benefits. When used correctly, data and the information that's gleaned from it can drive smarter and faster business decisions. For example, a company might gather about the performance of their ads or content, They could organize and interpret that data to produce a wealth of insights like what types of graphics, phrases, and even products are most appealing to their customer base. They may also be able to develop a more comprehensive understanding of their target audience, which can help them make decisions about future offerings, branding, and communication preferences. The right data can lead to nearly limitless information and insights, all invaluable for decision making. To create a truly effective data-driven culture, it's critical that you maintain the information and insights gleaned from data in a centralized source that's available organization wide like a knowledge management system, implement protocols to ensure data quality, and cultivate analytic skills across all departments. Data and information are both critical elements in business decision making. By understanding how these components work together, you can move your business toward a more data and insights driven culture. So, in short, understanding the difference between data and information is crucial for businesses. Data is raw and unprocessed, while information is derived from data through analysis and interpretation. By collecting and analyzing data effectively, businesses can gain valuable insights that drive smarter decision making. These insights help valuable insight that This insight help identify customer preferences, improve advertising strategies, and inform future business decisions. So, this enables businesses to make informed decisions based on reliable and valuable information. Next, data interpretation. Data interpretation is the process of making sense out of a collection of data that has been processed. This collection may be present in various forms like bar graphs, line charts, and tabular forms and other similar forms, and hence needs an interpretation of some kind. In other terms, it involves analyzing and understanding processed data, which can be presented in various forms like graphs and tables. It helps in extracting meaningful insights from the data. Next, data visualization. Data visualization is a graphical representation of information and data. By applying visual elements like charts, graphs, and maps, data visualization tools give a convenient way to see and understand trends, outliers, and patterns in data. In the world of big data, data visualization tools and technologies are necessary to interpret massive amounts of data and make data-driven judgment. In short, data visualization uses charts, graphs, and maps to show information visually. It helps us to understand trends and patterns in data. In the world of big data, it's essential for interpreting large amounts of data and making informed business. Next, types of data interpretation. So, number one, tabular DI. In it, data is provided in horizontal rows and vertical columns called tabular form. A table is one of the simplest and most convenient tools used for summarizing data and presenting it in a meaningful way. In a table, data is arranged systematically in columns and rows. Number 2, pie charts. It is a circular chart divided in various sectors. The sectors of the circle are constructed in such a way that the area of each sector is proportional to the corresponding values of information provided. Number 3, bar graph is in this section, data is represented as horizontal or vertical bars. One of the parameters is given on the x-axis and other on y-axis. Number 4, line graph. Line graph shows the quantitative information or relationship between two changing quantities with a line or curve. A line graph or a line chart is a geographical representation of the change in two variables over a period of time. And last, caselet DI. In caselet DI, a long paragraph is provided, and with that as the basis, some set of questions are asked. Next, let's jump to tips on solving data interpretation. When solving data interpretation problems, consider the following tips. Number 1. Read the entire question carefully. Read the complete data given in the form of values, graph, etc. Number 2. Analyze the data. Take a look and analyze the data carefully. Don't get diverted or afraid due to a lot of information, and avoid skipping the information before giving a glance to it. Number 3. Pay attention to the units. Many times, different units are used in one question. For example, speed is given in km per hour, and time is to be calculated in seconds. 4. Use of approximation. If the options are adequately far apart, then you can approximate values, fractions, and percentages to nearby numbers, which can ease our calculations. Number 5. Use of last digit. Check if all options have different last digit, then to find the correct option, we can just calculate the last digit of our answer. But then approximation is not at all allowed. Number 6. Mental calculation. Try to do mental calculation as frequently as possible while practicing. 7. It will help in minimizing the time to solve the question. Number 8. Remember the following relations. So by applying these steps, you can enhance your problem-solving skills and tackle data interpretation questions more effectively. And now the conclusion. All of the different types of data have a critical place in technology, statistics, research, and data science. Data types work great together to help organizations and businesses from all industries build successful data-driven decision-making process. Working in the data management area and having a good range of data science skills involves a deep understanding of various types of data and when to apply them. So, in simple terms, data is important in technology, research, and data science. There are different types of data, and each type is valuable for making decisions based on data. It's important for people working with data to understand these types of data and how to analyze them. By using different types of data, organizations can improve their decision making and be successful in their data-driven efforts. So that's the end of Chapter 1.1 Data and Data Interpretation. I hope you guys understand the importance and types of data. Thank you for listening.